do a little bit of work with rational expressions. Suppose I have the following rational expression, x squared plus 7x plus 10 divided by x squared minus 3x plus 10. What is this in simplest form? Well, I need to factor both numerator and denominator. The numerator factors into x plus 5, x plus 2, and the denominator factors into x minus 5 times x plus 2. Now, as soon as you get your ratio here fully factored, go ahead and state your restrictions. These are going to be where the denominator is 0. So x cannot equal 5 or negative 2. So once you write that down, you're good. When I come over here, I see that I can cancel terms out. So this is equal to x plus 5, x minus 5. So this is this rational expression in simplest form. It's going to have a vertical asymptote at x equals 5, a horizontal asymptote of y equal to 1, because the coefficients of the leading terms are 1 and they're of the same power. And it's going to have a whole at x equal to negative 2. Now let's go and try some rational expressions with different letters. If I have 3x divided by 35y times 49y divided by 12z, you can multiply straight across because you're multiplying. All right, so this is the same thing as 3 times x times 49 times y divided by 35 times y times 12 times z. Now, I'm going to take these down to their primes. So this is 3 times x times 7 times y. 35 is 7 times 5 times y. 12 is 2 times 2 times 3. And then we have a z. There is a reason I'm doing it this meticulously. Now, once we have everything broken down into its primes, we can start simplifying. I have a 3 in the numerator. That will cancel with the 3 in the denominator. I don't have any x's in the denominator. I have a 7 in the denominator, but just 1. And I have a y. The y's cancel. So let me see what I'm left with in the numerator. I'm left with a 7 and an x. And in the denominator, I'm left with 5, 2, 2, and z. So this is 20z. Now, what about when I have polynomials where I've got sums and stuff? You want to do the exact same thing. You want to factor it as best you can. You see how I put those big parentheses in there? Go ahead and do that. The numerator will be x minus 2 times 10 times x. And the denominator will be 5x times, put those parentheses in there, 3x squared minus 12. All right, so let me come through and factor. I'm going to take this 10x times x minus 2, just rearrange it a little bit. This is 5x. Now let's see, what can I do with this? I can factor a 3 out, and I'm going to have x squared minus 4. Let me finish factoring this. 10x times x minus 2 divided by, what is that, 15x. Now I can factor the x squared minus 4 into x minus 2, x plus 2. Now I have it in factored form. So now I can put my restrictions. before I do anything else. X cannot equal 0, 2, or negative 2. Now I can come through and continue with the simplifying. X will reduce with x. X minus 2 will reduce with x minus 2. Now 10 is 5 times 2, while 15 is 5 times 3, so the 5s will cancel. Let's see what we're left with. In the numerator, I'm left with 2 times 1 times 1, so that's just 2. In the denominator, I'm left with 3x plus 2. And there's really not much more you can do. Now it's going to get to be a lot of fun. When you're doing rationals like this, go on and put those big parentheses. And I'm going to go on and factor these. This first one factors into x plus 3, x minus 2. This first term is x minus 5, and I'm going to put those parentheses on there, times. Now x squared minus 25 is x minus 5 times x plus 5. And x squared plus 4x plus 3 multiplies into x plus 3 times x plus 1. Now you technically don't have to rewrite it as one fraction. Let me put my restrictions on. X cannot equal 5, negative 3, or negative 1. You find that by looking at the denominator. And anything that makes that denominator 0 is forbidden. So now let's see what all simplifies. I have an x plus 5 and an x minus 5 and an x minus 5. Do I have x plus 3? I have an x plus 3. I think that's it. So my numerator is x minus 2 times x plus 5, and that's divided by x plus 1. So I'm going to have a vertical asymptote at x equal negative 1, a whole at x equal 5 and negative 3. Oh, now do you remember division? All right. Saying 3x over 4y divided by 6x over 5y is the same thing as saying 3x 4y times, you multiply by the reciprocal. Now at this point in time, I'm going to stop you and tell you you need to write your restrictions. Your restrictions, however, are going to include 3 terms. Okay? Look at your original denominator. Y cannot equal 0. X cannot equal 0. But z cannot equal 0 either, because it was in the denominator of this first equation. So, once I've done this, let's see if I can simplify it all. Let's see. Yeah, I can actually cancel out an x. That's kind of interesting. So 3 times 5 is 15z divided by 24y. Now, what do you do when you have polynomials? Well, the first thing you're going to do is factor. So this is 7 times x plus 2 divided by, use your parentheses, x minus 1. And that's divided by, this is 7 times x squared minus 4 divided by 5 x squared minus 1. You're not fully factored yet, so let's fully factor. 7 x plus 2 divided by x minus 1, and put those parentheses in there, divided by 7 x minus 2, x plus 2, divided by 5 x minus 1, x plus 1. Now write this as a multiplication. You're going to invert and multiply. This is 7 x plus 2 divided by x minus 1, use your parentheses, times, now we're going to flip this, 5 times x minus 1, x plus 1, divided by 7 x minus 2, x plus 2. Now you need to write your restrictions. Okay, x cannot equal negative 1. It cannot equal 2, negative 2. And you've got to go back to this original equation. Okay, you can kind of think of it this way. It'll be the two denominators and then the second numerator. X also cannot equal positive 1. Once I've written the restrictions, I can go back and start simplifying. Let's see, I have a 7 in both numerator and denominator. I have an x minus 1. I have x plus 2. Am I left with anything? This is going to be 5 times x plus 1 divided by x minus 2. The fun keeps getting funner. Now, let me go on and start my factoring here. I'm going to put my big parentheses in so I don't lose myself. I'm going to do that again. That wasn't very good. Now, in the numerator, I'm going to factor out negative 1 because that's kind of a standard form. This is x plus 1 squared. So that's my first term. And it's divided by, let's see, this one is going to be, it multiplies to be 5, excuse me, multiplies to be 10, adds to be 3. So x plus 5, oops, x minus 2 divided by x minus 1, x plus 1. So my restrictions are going to be x cannot equal negative 1. It cannot equal positive 1. Okay. Let me go on and do the division here. Got ahead of myself there. Okay, so I've done the restrictions for x can't be negative 1, positive 1. It also cannot equal negative 5 or 2. So I have 4 restrictions on this one. And now let's see if we can simplify. See why I took the negative 1 out of here. I have x minus 2 and x minus 2. I have 1, x plus 1, that will reduce. So let's see if I've done enough. Indeed,